Sorry about this.
All right. Well, good afternoon, everyone. Welcome to today's Exploring by the Seat of Your Pants Hangout. My name is Joe Gabrowski, and I'll be your host for today. If you've been tuning in this month, we've been celebrating amazing women in science, exploration, adventure, and conservation, making connections all over the world. It's been a ton of fun so far. We're going to carry on today with our next event. Today, we are going to hang out with Dr. Ellen Stofan. So she has 25 years of experience in space administration and planetary science. So before becoming the director at the National Air and Space Museum, she was previously chief scientist at NASA, working with a whole range of different programs. She was also a senior scientist at NASA's Jet Propulsion Laboratory, or JPL, working on missions exploring Venus, Earth, Mars, and Saturn. So Ellen, it is so great to have you joining us live today. We're excited to hang out, learn a little bit more about you and some of your adventures, and of course, we'll take some questions from our classrooms joining us.
Excellent. Thank you so much for having me here today. And, you know, being able to reach out and talk to kids is actually the favorite thing that I get to do. So this is incredibly fun. So just to give you guys a little bit of background about me, I am a planetary geologist, which means that I study volcanoes around the solar system. And some of you might say, why do we study volcanoes around the solar system? You know, the whole reason NASA has spent the last 60 years studying the planets is because we're really trying to understand, how does the Earth work? So when we go out to planets like Venus or Mars, or even the outer planets of the solar system, we're really trying to figure out, are there things from studying other planets that we can turn around and help us to understand this planet better? For example, you guys all know about climate change, and that's obviously a huge topic, and trying to understand the Earth is to be able to understand, how is our climate changing? Why is our climate changing? And how can we better predict what's going to happen in the future? Well, it's all very well to have one planet to study, but, you know, we can compare Earth to Venus, for example, whose atmosphere is almost entirely made up of carbon dioxide. And because of that huge greenhouse effect on Venus, it's over 750 degrees Fahrenheit on the surface. Lead actually melts on the surface of Venus because of a greenhouse effect. Now, Mars only has a little bit of CO2 in its atmosphere. It's cold. So a lot of the times when people are asking me about climate change, I get asked, how do you really understand the role of CO2? And one of the things that I can say is, one of the reasons we understand it so well is because we don't just have one planet to study. We have the atmosphere of Mars. We have the atmosphere of Venus. We actually even have the atmosphere of a moon called Titan, which is one of the moons of Saturn, that actually has a dominantly nitrogen atmosphere, which is, of course, the gas that makes up most of Earth's atmosphere. The other reason we spend a lot of time exploring the planets is really to answer a question that I think is pretty fundamental to how we think about everything. And that question is, are we alone? Is there life beyond Earth? Are there places we can go in the solar system to really understand, is there life? Well, you guys probably know that here on Earth, life originated in the oceans actually pretty soon after conditions on this planet stabilized, about 3.8, 3.9 billion years ago. So it turns out that about 3.9 billion years ago on Mars, the conditions were pretty similar to those on the early Earth. So if there was water, if there were the organic molecules that make up us, and we know those have been delivered around the solar system by comets and asteroids. So if those conditions on Mars were so similar to the conditions on Earth when life originated, shouldn't there have been life on Mars also? The issue was, on Mars, after about 500 million years, a billion years, it started to lose its atmosphere because it lost its magnetic field. Whole other complicated story on how planets' magnetic fields work. But without that magnetic field, the atmosphere of Mars started getting stripped away by particles streaming from the sun that we call the solar wind. And Mars became cold and dry and kind of uninhabitable. So the question was, did life go extinct on Mars? Or did it go underground where it could be protected away from the harsh conditions on the surface? So big questions about that. We even wonder if there could be life underneath the icy crusts of some of Saturn's moons and Jupiter's moons. So all of a sudden, we have all these targets to go in our solar system to search for life. Well, in the meantime, while people like me are worrying about what's going on in the solar system, I have colleagues who've been studying planets around other stars. And in about the last 10 years, we've discovered over 2,600 planets around other stars. And some of those sit the right distance from their parent star, where we could say, you know, maybe there could be water on the surface, maybe there's an atmosphere. So can we find sort of Earth 2.0 around another star? Now, that's one of the reasons we actually want to figure out how common was life in ours, or is life in our solar system, because now we're not just studying our solar system. We actually now have the ability with some of our advanced telescopes, including the James Webb Space Telescope that'll be launched in about 2 years, to start studying the atmospheres of planets around other stars. So we can really start answering this question that, again, I think humans have wondered about ever since we could look up at the night sky is, are we alone? Is there life on around one of those other little bright twinkly stars that we see up in the sky? In the meantime, of course, NASA's working on getting humans to Mars. And you guys are actually what we call the Mars generation, because you're about the right age that someone from your class, one of you, might actually be the first person to walk on Mars. Because we think about 20 years from now or so, we'll be ready to land humans on the red planet. And those people have work to do because they've got to break open a lot of rocks, find that evidence of past life, so we can look at things and say, how similar was life that evolved on a different world? How similar is it to life here? And can we actually use that information to help understand life in the universe? Now, my current job is really fun because at the Air and Space Museum, we're actually rebuilding the whole inside of the museum. The museum was kind of falling down, another long story, not built very well. Okay, so we're going to fix the building, but it gives us a chance to say, what are the stories that people like you guys want to hear? What are the things that are happening in space with airplanes that you think are exciting? From supersonic flight, are we actually going to be able to fly from California to the East Coast in maybe 2 hours instead of 5, the way it's been taking for about the last 40 years? Are we going to have artificial intelligence? How is that going to change how airplanes fly? How willing would you guys be to get on an airplane without a pilot, just powered by a computer? These are questions that are really in front of you guys. So I'd be curious from you guys what kind of things you would love to see in a renovated Air and Space Museum. And I have a feeling one of the things you'd be pretty excited to see is something we actually got last week. I had this guy named Richard Branson here. I don't know if any of you have ever heard of him. He's kind of a billionaire entrepreneur guy who founded Virgin Airlines, Virgin Music, all these different companies. But one of the companies he founded is a company called Virgin Galactic. And about a month and a half, or about 2 months ago now, Virgin Galactic actually became the first company to make it to space. So private company, not funded by the government. Their 2 test pilots made it up to about 52 miles above the Earth's surface, which counts as space. Stuff floated around in the cockpit. And they came back safely to Earth. So Virgin Galactic in the next year or so is actually going to start taking just, okay, not average people, because maybe I couldn't afford it. A lot of us can't afford to pay the cost of their ticket, but it's actually going to be space tourism. So just people who feel like going to space, regular people with a lot of money, will be able to go to space. The idea he has is, though, how can we bring down the cost so pretty soon everyone can go into space? So anyway, Virgin Galactic, from that first successful flight, they gave us at the Air and Space Museum the rocket motor that actually helped them get up to space. They donated their rocket engine, and we got to unveil it in the museum last week, which was really fun. So I prefer answering questions to talking. So I'm really curious what you guys want to talk about, whether it's life in the solar system, aliens, planets, the museum. Let's go. Lots of questions, please.
All right. Very cool. Well, Ellen, thank you so much for sharing with us to get started. Before we do meet the classrooms, though, I want to turn the spotlight on you for a moment, and I want to steal a little bit of backstory. So I want to know, and I think the classrooms would like to know, JPL is a really cool organization. In November, we hosted tons of scientists and others who work at JPL for events. What was your first gig at JPL, and how did you land that job?
Well, you know, it's a funny question because when I started out, actually, this is sorry to give you I'll try to rush through the story. So when I was 14, my dad worked for NASA, so not a typical story, right? And he was in charge of he was in charge of the rocket that was launching the first 2 landers to Mars, called the Viking landers. And we went down to the launch, and I kind of knew I wanted to be a scientist, but beyond that, I was not too convinced. 14, not sure. I'm sure the age of some of you guys out there. And I went to this talk that they put on for the families of the NASA families that were down there. And there was this guy named Carl Sagan, who most of you haven't heard of, really famous planetary scientist. And he was talking about why we were going to Mars, the exact stuff I've been talking to you guys about, looking for life on Mars, wanting to do it. I was like, okay, that's what I want to do. I want to be one of those people studying Mars. So fast forward, I go to undergrad at William & Mary. I go to graduate school at Brown. I finish, and I'm looking for a job, and I get offered a postdoc at Brown University. And a postdoc at JPL. I was so excited. So I had done a little bit of work on Mars in graduate school, but I mostly started studying Venus because there was a NASA mission that was getting ready to go called Magellan that was going to go to Venus. And I thought, well, I like Mars, but let me study Venus. So I got offered a job at JPL to work on the Magellan mission. It went into orbit around Venus about 4 months after I got to JPL. So when the images started coming down from Magellan, I got to be like one of the first people on this planet to ever look at these different parts of Venus that no one had ever seen before. And I realized the cool thing about being at JPL was I could explore the solar system. I could have first, like being the first person to look at this place on another world. And I actually never had to leave, my office, which for me, I'm not very adventurous. But I like to explore. So being a planetary scientist, for those of us who maybe not, like a lot of the people you talk to, Joe, love to put themselves physically out there. I like to put myself mentally out there. So going to JPL was really fun because of that.
All right, very cool. Well, I think it fits in nicely with exploring by the seat of your pants, in that we can go anywhere in the world now, and then off the world, and you don't have to leave your seat if you don't want to. So
exactly.
All right, very cool. Well, and we have a full house of classrooms joining us, so let's get meeting some of them and take some of their questions. And then boys and girls, if you guys do a little brainstorming, you think of something really cool that you'd like to see in the Air and Space Museum, you can maybe make that suggestion as well. So let's start meeting some of our classrooms. Let's see. Let's go to Freehold, New Jersey first. We're going to go to Mrs. Reading's class, and we'll let them have the first question. So let's get their microphone on. There we go. How we doing, New Jersey?
Good. Oh, hi. So, I'm a NASA buff, obsessed. I went to space camp this summer, adult space camp. So my kids, they don't have a choice. It's like NASA all day in here. But no, for real. So, so they have maybe some like higher level questions just because they have some background knowledge. So I just want to let you know that. So okay. Go ahead.
NASA is funded by taxpayers. Does that impact the choices they make about missions?
That's a really good question. And how NASA actually makes its decisions of what to do next. Do we go to Mars? Do we worry about, going to Europa, or how do we balance like looking out into the universe or studying this planet? NASA is funded by taxpayer dollar. And in fact, if you think of a dollar bill, and if you think of that dollar bill as being the entire US government budget, 1/2 of 1 penny comes to NASA. So that gives you an idea of sort of where NASA fits in the relative. So 1/2 of 1 penny of every dollar of the federal budget comes to NASA. So NASA actually turns to the US National Academy of Sciences, which is a group of people from around the country. They bring in scientists from all over the US, and they have big arguments about what should NASA do next? How should NASA spend its money? And, the government really likes this because they feel like it's a really good way to make sure that NASA is always spending its money on the highest priority, smartest things. And that's what we've done for a while. The other thing that Congress really likes about it is there's been a bunch of different studies done. And it turns out for every dollar that's spent at NASA, actually about somewhere between $3 and $5 actually comes back into the United States economy, because NASA, when they're trying to do hard things like go to the moon, go to Mars, send spacecraft around the solar system, you invent things that you can use here on Earth, from really practical things like the water purification system we use on the International Space Station. They actually have a small version of it that they take into disaster areas around the world. Most baby formulas have a nutritional supplement that was actually developed for astronauts on the International Space Station. And also we have things like this, the cameras in your cell phones actually come from NASA technology. So where you least expect it, NASA technology has actually improved our lives, actually including in ski boots, one of my favorite NASA spinoffs. Thank you for the question.
Very cool. Great question to get us started. And you should take another look around you at your cell phone and other things and just wonder where some of that technology came from. Let's go to San Antonio, Texas this time. We're going to visit Mrs. Meineke's class. Let's get their microphone turned on. There it is. How are we doing, boys and girls?
Hi, I'm Allegra, and my question is, what is the most fascinating information you learned about Venus?
That's a great question, and I really love Venus. And, when you think about Venus, Venus is a really fun planet to study because Venus is the same size as the Earth. It's made of the same kind of stuff as the Earth, the same kind of rock, the same gases as the Earth. But it's like you started with sort of two chocolate cake mixes. You put both of the pans in the oven, and one came out a chocolate cake, and one came out a lemon cake. And that's the Earth and Venus. Sometimes we call them evil twin. Venus is Earth's evil twin. Because again, the planets are so similar. And yet here, Venus is just this incredibly hot place where nothing can live. And what we really try to understand from Venus is, why did the Earth turn out just right? And why is Venus too hot? And there's actually something called the Goldilocks hypothesis, trying to understand why Mars is too cold, Venus is too hot, and the Earth is just right. So to me, again, it's sort of why I love Venus, and the most interesting things about it to me are things that help us understand this planet better.
All right, great question. We're going to take a trip now. We're going to go to Canada. We're going to go to Amherst U, where we have Mr. Richard's class hanging out with us, some grade 5-6 students, and they've got their kindergarten buddies have joined them today. So even more joining us for the fun. Let's get their microphone turned on. There it is. How's it going, boys and girls?
Good. Hi. Great. Go ahead, John.
When you said planets beyond the stars, does that mean there could be other planets we could live on and other life forms?
Great question, and yes, and yes. So the Kepler Space Telescope, which is this really cool telescope that NASA, it actually unfortunately is no longer operating because some of the parts of it broke. But the Kepler Space Telescope is this telescope that discovered over 3,000 planets around other stars. And so what it actually does is it stared at individual stars, just stared and stared at them. And whenever a planet would pass in front of the star, like sometimes there's an eclipse here on Earth, that's like when the moon passes in between the sun and the Earth. Well, that's the exact kind of thing that Kepler was looking at. It was looking for a planet to pass in front of a star, and then it could figure out, like, how big is that planet? Is it the same size as the Earth? So that's how we figured out there's all these planets out there, many of them about the size of the Earth, and again, sort of the right distance, maybe from their parent star, to have water. So one of the big questions we have is, if the life evolved on Earth, maybe it evolved on Mars, maybe some other places in our solar system. If you have these conditions, and you know that the molecules were made of basic things that are called amino acids, that are kind of the basis for life on Earth. We've actually been able to detect those in various places out in interstellar clouds, and again in comets and asteroids. If those building blocks of life were everywhere, you kind of start expecting, well, there are billions of planets and billions of stars. Somewhere there has to be another Earth. So there's actually a man named Frank Drake. He's still alive, and he actually wrote an equation, so a math equation called Drake's equation. And he tried to actually say, can I use math to sort of help us guess how common life might be in the solar system? And some of the variables in the equation are like, how many stars are out there? How many planets out there? Is there some number I can assign to how likely it is to get life? So anyway, we used the Drake equation, and the answer came back, yeah, there's got to be Earth-like planets out there somewhere. If there's that many Earth-like planets, somewhere there has to be life. If there's life, could there have been stable enough conditions, not just for life to evolve and get like microorganisms like algae or single cell bacteria, but could it have the time for life to get complex? Remember, it took billions of years to go from the first occurrence of life on Earth to land animals and plants and then us. So if you need those stable conditions for billions of years. But basically the Drake equation sort of indicates that to go back to the simple answer, yes, there should be other complex life out there. And yes, some of those planets around other stars should be like Earth. The problem becomes we use basically the same propulsion technology that we lived when we sent, when we sent humans to the moon 50 years ago. So you might see movies where they have like warp drive and they can, you know, go into hyperspeed and go between stars. No one's invented that yet. So your assignment for all of you tonight is go home, invent warp drive, and we'll go visit those planets around other stars.
All right, that's an easy bit of homework. I'm sure someone's going to come up with it tonight. All right, let's go to Guelph, Ontario. We've got some grade 6s hanging out with Mrs. Hug. Let's get their microphone turned on. How are we doing, grade 6?
Hi.
Hi.
All right. Did you confirm Planet X is the 9th planet?
You know, oh my gosh, you wanna see a bunch of scientists get angry at each other. You bring up Planet X, you bring up whether Pluto is a planet or not, and all of a sudden you've got scientists shaking their fingers at each other and shouting. And no, we haven't confirmed it yet. There is a lot of theory that suggests that Planet X is out there, but we haven't had a direct or even an indirect detection. Now, there's some claim there's an indirect detection, and by that, I mean, the idea is if there is another planet, like way out beyond Pluto, way out beyond the Kuiper Belt, it would maybe cause all the planets, because of its gravity, to behave slightly differently. And that's one of the how they came up with Planet X in the first place. They said, well, if you look at the orbits of planets and how they behave, it suggests there could be something out beyond the Kuiper Belt, which is where Pluto is. But it's not been detected. And I tell you, Alan Stern, who's a scientist friend of mine who was in charge of the Pluto mission, and he is so mad that Pluto is not still classified as a planet. So when people started talking about Planet X being the 9th planet, he's been really mad because he's like, no, Pluto is the 9th planet. So if there is a Planet X, I'm not going to comment on whether it's the 9th planet or the 10th planet, because then I'll have lots of scientists either happy with me or angry with me. So I try to stay out of it. But it's a great question. It just goes to show how much work there is left for all of you guys and why it's so important all of you become STEM scientists. There's these planets around other stars. There's Planet X. We have more questions than we have answers. So we need STEM recruits to come help us understand all this stuff.
All right, very cool. Best to stay neutral. I think you're making a good choice. We're going to go to Newmarket, Alabama this time to visit Mrs. Moore's class. Let's get their microphone turned on. Where is it? There it is.
Hello! Okay, all right, sit down. We have a student with a question. Yep. Landon, go ahead.
Come on up here.
Okay, go ahead, Landon.
I'm asking this for my friend Lucas because he's not allowed to be on camera. But his question for you was, what is your favorite planet and why?
You know, I have 3 children, you know, and they're always trying to get me to say, you guys must do this with your parents. They're always trying to get me to say who's my favorite kid. I love all my children equally. But I have to say my favorite planet is actually not a planet, it's a moon. And it's this moon called Titan. It's a moon of Saturn. It's actually Saturn's largest moon. It's the only moon in the atmosphere, in the solar system that actually has an atmosphere. I mentioned it earlier. But the thing I love about Titan is it's the only other body in the solar system with expanses of liquids. It has rivers, it has lakes, it has seas. The only other place there are liquids on the surface besides Earth in our entire solar system. But, you know, remember I said this is a moon of Saturn. So it's like minus 200 degrees on the surface. So you're like, how can you have liquids? How can you have rivers if it's minus 200 degrees? Well, the fluid in the rivers is not water. It's actually basically liquid gasoline. It's liquid methane and liquid ethane. That's what's the liquid at those temperatures. So you guys have learned about the water cycle, right? You know, precipitation, condensation, all those words. I always get them mixed up. So Titan has exactly that same cycle, except the fluid that rains down, and it does rain on Titan, again, is not water. It's basically liquid gasoline. So the idea, you know, I was talking, right, about life, water, life evolved in Earth's oceans. So the really fun question for Titan is, could there actually be life in those seas on Titan? You know, do you have to have water or do you just need a fluid? So I spent about 5 years designing a mission that would be a boat that would splash down in one of these seas on Titan and look for life. And it was this really cool mission, and we made it really far through the NASA proposal process. And then we got beat by a mission to Mars. So the Titan boat's not going to probably happen for another 20 years. And it's super disappointing. But you know what? What's important is something that is a lesson for everybody. You know, sometimes you try things and they don't work. They fail. So I had this huge failure, right? My Titan boat didn't get selected. I still love Titan. We're still studying Titan. And now I'm on actually a mission proposal to send a drone to Titan to fly around in Titan. So it's the whole, if you don't succeed, try again.
All right. I think that's an awesome point. There's nothing wrong with failure. It's a natural part of life. It's what you do afterwards, what you learn, get back up, dust yourself off, and try again. All right. Let's go now to Colchester, Connecticut. We're going to visit Mrs. Kronecki's grade 6s. Let's get their microphone turned on.
Hi.
Grade 6s.
Hi.
Hey, guys.
Go ahead, Ivy. Ivy has a question first.
How fun is it to work at the Space Museum exactly? Like, does anything interesting happen?
Well, you know, when I got this job, the first question my kids asked me, and they're grown up, they're like in their 20s. The first thing they asked me is, do we get to go sit in the space shuttle or sit in the airplanes? And can we come stay overnight just to see if like Amelia Earhart or that Night at the Museum stuff is actually true? And the answer to all those things are no. We can't get in the space shuttle. We can't touch things. And I'm pretty sure that nothing comes to life in the museum at night, though I'm not 100%. I've never witnessed it, so I can't say for sure. But, you know, being in this museum every day is amazing for so many reasons. For example, just today I was downstairs and I walked by Amelia Earhart's plane, which is, you guys know Amelia Earhart was a famous woman pilot, one of the first really famous women pilots. And she's unfortunately mostly famous because she was trying to fly around the world and she crashed probably somewhere in the Pacific and died. But it's fun we have one of her airplanes that she flew earlier before she died. But we get a lot of visitors who say, is that the airplane that Amelia Earhart disappeared in? You're like, no, think about that. How would we have the airplane, right, if she disappeared in it? We have a moon rock here that you can touch, which is really amazing to say you're touching a piece of the moon. And we have Neil Armstrong's spacesuit, which is really cool. We're in the process of restoring it. And it's actually really dirty from the knees down because the lunar dust is so fine that the moon dust is actually stuck in his suit. So you're like, oh, that's dirty. And then you realize, Oh no, that's really cool. It's got moons stuck all over it. So, you know, just so many cool things that are in this museum. But what I love is that each one of them is the story of people who had an idea that in general, people said to them, that's not possible. I mean, Orville and Wilbur Wright, you know, who were the first pilots, were told it's impossible to fly, but they did it. Bessie Coleman was an African-American woman who wanted to get her pilot's license. And in the US, she was told you can't. So she actually went to France, got a pilot's license, and came back and was the first African-American woman who flew in the United States. So all these stories from the Air and Space Museum are stories of people who were told, no, you can't, but they did it anyway. And I think that's important for all you guys. If people ever tell you no or you can't, for example, I used to get C's in math class, and I thought, am I really going to be able to be a scientist? But, you know, don't take no for an answer. You just keep doing it.
All right. Let's take a trip to Austin, Texas. We've got grade 8s hanging out with Mrs. Hand. How's it going, grade 8?
Good. So my question was NOAA documentary on, or part of it was determining the gas makeup of the atmosphere or the gases in a star by doing a light. I can't remember what it's called, but have you ever worked with that, and like how does that work?
I haven't worked with it, but I know how it works, and I'm holding onto my computer, so I can't wave my hands around, which is always a bad thing for me. I like to wave my hands when I talk. So I'm trying to move this where you guys can see me. So the way it works is when we're trying to study the light or the atmosphere of a planet, we do it, if my fist, can you guys see my fist? My fist is the star, and this is the planet coming in front of the star. So as the planet goes to pass in front of the star, think about it, the atmosphere sticks out from the planet, right? So the first thing you have is the atmosphere of the planet going in front of the light from the star. And believe it or not, just that light from the star passing through the atmosphere allows us to measure what gases are in that atmosphere. So when the planet passes in front of the star, you get atmosphere, planet, and then atmosphere again. So every time a planet, we call it an occultation method, every time that the light from the star can pass through the atmosphere of the planet, we can measure what gases are in it. So if you think about it, if we're looking for life, we're looking for gases like oxygen, carbon dioxide, methane, gases that here on this planet are associated with life. We can do that with some ground-based telescopes, but this telescope I mentioned earlier, the James Webb Space Telescope, that's going to be able to look at Earth-sized planets around other stars and measure their atmosphere. And it's going to do that in about 5 or 6 years. And again, that's why I'm so excited for you guys, because by the time you're in college and you're going to be having all this data from planets all around our galaxy, and you're going to be able to compare them to like the gases here on Earth, on other planets in our solar system. We're going to be learning so much. It's going to be really exciting.
All right, and our final live classroom is joining us from Erie, Pennsylvania. We've got some high schoolers hanging out with Mrs. Smock. Let's get their microphone turned on. How are we doing, grade 11?
My question is what is the most unique thing you ever found of a planet, either gas-wise or physical-wise, and why?
Yep, big facts.
You know, that's a great question, and I think there's a couple different ways to look at it. In different, one of the, you know, I told you guys about the those rivers and seas on Titan. So I was part of a team on the Cassini spacecraft, which is a NASA mission that was in orbit around Saturn. And we got this data back, and we all started arguing about what it meant. And it turned out it was the discovery of those seas of liquid gasoline on Titan. So I got to be part of that discovery, which was really exciting. I think, to me, the most surprising thing is every time we go out and find something that's so similar to life on Earth. The other really fun thing, and this was when I was chief scientist of NASA, is I got to learn a lot about the work we do on trying to understand astronaut health. And it's one thing you guys might not know. We have you know, doctors, physical therapists, nurses, all kinds of different people who work for NASA who are working with the astronauts trying to say, how do you keep us healthy in space? And it's really fascinating. I mean, some bacteria actually become much more nasty, much more virulent in space. Other bacteria become less. So it turns out space has the lack of gravity when you're out in space really changes the human body. It changes living organisms in ways that are not very predictable. And that's going to help us learn a lot more about life. So some of the more surprising things have actually, to me, not been so much about planets, but actually learning about humans from going to space, which is kind of a surprising thing right there.
All right. Well, Ellen, I want to squeeze in one question from the YouTube community who's tuning in to today's Hangout. And actually, it's Mrs. Gill's class who's tuning in. And let me just get the student's name so I make sure that I include it. Mahi. He's wondering about a theory of life, that maybe life was on Mars first, and that's what seeded life on Earth. What do you think about that theory?
That is a theory. It's called Panspermia. And so the idea is, remember, I went through that whole thing about how conditions on Mars and the conditions on Earth, so much the same. All right, well, what if life, you know, we say, well, life originated here on Earth, right? Well, again, what if it originated on Mars? And we know that Mars and Earth have exchanged material. Now, what does that mean? Well, at the time, about 4 billion years ago, 3.8 billion years ago, when life evolved, there were these giant impacts that were taking place. And that's why when we look at the moon and we see those giant impact basins on the moon, that same thing was happening to Earth and Mars. They were being bombarded by very large asteroids, very large comets. They would hit Mars and the Earth so hard that mathematically, it was first predicted, you could actually eject material from Earth that would make it to Mars, and you could eject material from Mars that would make it to Earth. Now, theory, right? Okay, you might say, well, that never happened. All right, in our collection of meteorites that we have here at the Smithsonian, we actually have about 10 different pieces of Mars that we have found here on Earth. So it did happen. So that could have happened. So one of the things we're really curious about life on Mars is, when we find it, will it have things like DNA and RNA that are just like life here on Earth that would suggest that is actually what happened? Then that makes us even more curious about finding life on the moons of Jupiter, at the moons of Saturn, because no material was exchanged between the inner solar system and the outer solar system. So that would actually be two different origins of life. So lots of questions. And you know what the amazing thing is? They're going to get answered in the next 15 to 20 years. So fasten your seatbelt.
All right. Well, we do live in an exciting time where there are far more questions than answers. So there are so many really exciting STEM careers, both on our planet and outside of our planet for students. So it is really an exciting time. Ellen, I know that our classrooms could ask you questions all day. So is it okay if they tweet some questions to you later if they have more?
That would be great. I would love that.
Okay. So at Ellen Stofan, you can find her on Ellen on Twitter, and feel free to fire away with some more questions. Ellen, it's such a pleasure to be able to steal some of your time. Thank you so much for hanging out with us in February, and today being such an important day, International Day of Women in Science and STEM. So thank you so much for joining us today.
Thanks. And can I do one more really quick thing before we go?
Of course.
I just want to show you guys a wall in my office. Can you see it?
Yep.
Now, all of these women on my wall are women who broke barriers, who went faster, who went higher, women like Mae Jemison, women like Bessie Coleman, women like Kathy Sullivan. So I just wanted to let your students see, I look at those women on my wall every day and I get inspired, and I hope they inspire them also.
All right, amazing. Well, classrooms, thank you so much for your amazing questions. Last thing we'll do today is turn the microphones on. You guys can get nice and loud and say goodbye and thank you to Ellen, and then we'll sign off for today. So here we go. Let's get loud. Microphones coming on. Goodbye and thank you before we sign off.
Okay.
All right. Excellent job of that. Thank you so much, boys and girls. Ellen, thank you again. We have so many more events, probably another 30 or more events between now and the end of the month. So check them out on exploringbytheseat.com. And we'll see everybody soon. Thanks for hanging out today.